18. I think we might have been on 18 instead of 19. I don't remember doing either of the questions relating.
Okay, so you want us
Or
to go
no,
back
wait.
to 18?
There's only one question about the graph. Yeah, because I marked down everything we'd done while we were doing them, like the answers, and there's not one for 18. So I don't think we did it.
All right, let me grab 18. So the graphing problem here, it's always important to look at the answers first in a lot of these to try to like see if you notice anything, and you do in this case. Let me get the I call it the strategy of looking for what's the same and what's different. It's like, what's the same? Well, they'll have a y. Okay, they'll have a y. They have different slopes, -1/2, 2, 1/2, 1/2. So the slope, if you recall, is the number in front of x. Slope is the number in front of x. And then the b is the y-intercept. The y-intercept is where it crosses the y-axis. Okay, so I think it's easier to look at where does it cross the y-axis? Where does it cross this vertical line?
And
What's the numerical value where it crosses?
3.
3. So which of these has a b value of 3?
B and B.
Okay. So the only two differences between those is the slope. Okay. So the slope is always how much it goes up, called the rise, or down, but in this case, the rise over the run.
The run.
Run, or to the right, rise over to the right, rise over run. So you're essentially sort of like, and it'd be a lot easier if you had the graph in front of you, but it's like, okay, let me go up and then to the right. So how many up are you going? How many to the right are you going?
Two, one, and
If you have the
one
book in
and
front of you,
two.
so you're going up 1 from 3 to 5, like you're just counting squares. And I know it's hard on the screen, through a screen, but like might be good to
No,
look
I'm
at the
looking
book.
on the book too,
Okay.
and not because I start.
Okay, so
So I would go from 3
no, I
to
take that
4,
back.
right?
Yes, it is 1 and then 2. Yes. Okay. So
Okay.
the rise goes on top and the run goes on the bottom. So what is the rise over the run?
1/2.
1/2. So that is your
So
slope. So which is the answer, B or D?
B.
Yes. Yes, you got it.
All right. Any follow up to that?
It's just on the screen. I got confused because on the screen it looked like you went up from 3 to 5 instead of 3 to 4.
Well, so I was trying to show you, you can go up 2 and then to the right 4. That's okay. 2 over 4.
That just wasn't. Oh, so you
is
could do it
1/2.
either way.
Yes.
This wasn't one of the options because I was going to ask like if there's multiple points where it would intercept. It only probably only one of them will be an answer because that would be like the answer.
There's never going to be 2 answers. So if you're thinking there's 2 answers, you're doing something wrong. I mean, meaning just there's something else you got to consider.
But you can like if it's not like the first like the closest point where it would intercept like
You could. I was just trying to choose a different point just to show you that it doesn't matter. Like if you like you're saying if you go up 1 over 2, that's the 1 and the 2 there.
That's what I was wondering.
Okay. Let's look at 19 now. All right, what is the sixth term in the sequence below? So we got, maybe I'm grab a different color here. You got the first term, the second term, the third term, the fourth term, the fifth term, and the sixth term. Are there any that you feel like you can eliminate that you say, that doesn't quite look right?
Mm, not at a glance.
Okay. So the hardest thing, and this is not a math thing, is to determine the pattern. Like, how do you go from 1 to 3, 3 to 7, 7 to 15, 15 to 31? And I guess I just want you to stare at that for a full 30 seconds here. I'm going to just step away, but just stare at that. See if you can come up with any sort of rule that works. And I'll be right back with you. Okay. Do you notice any patterns when you look at this?
Mm,
So since they're going up, like, can you add the same number each time? Like to go from
no.
1 to 3? No.
Well, I'm sure it's multiplying at some, but I don't know what it would be.
So
So is it
like,
just times 3 every time?
well, that works for the first one, but does it work for the second one?
Yeah.
So that's the issue. It's like, well, and we haven't talked about this, but it could actually be a combination of them. Meaning you add and then multiply, or multiply and then add.
I don't know.
Okay. Yeah. See, and this is probably not a fair question, because it's more of a pattern recognition. It's like putting together a puzzle. I mean, just some people see the pieces go together. What I want you to see is that, do you see that 3 is kind of like half of 7, and 15 is, or 7 is about half of 15, and 15 is about half of 31?
Not at a glance, but I guess.
Okay, yeah, and that's the hard part here. So here's the rule. The rule is you multiply by 2 and then you add 1. So 1 times 2 is 2, plus 1 is 3. 3 times 2 is 6, plus 1 is 7. 15 times 2 is 30, plus 1 is
31.
31. So could you use that rule here to find the missing one, please?
$63.
All right. Any questions on that? Thoughts on that?
Mm-mm.
Okay. So let's do 20 differently. 'Cause they kind of do it in a weird way where they want you to put symbols in. I mean, I'm just surprised that that's part of this, but let's read it out loud. Let's see if we can work through it without kind of worrying about how to enter the answer at the moment. So here we go. Evening tickets to a play are $24.50 each. Okay, so if you want to go to a play in the evening, you're going to pay $24.50 for each ticket. If you want to go in the afternoon, it's $19 each. Okay, and Janice wants to buy 6 tickets. What we don't know is whether she wants to go to the evening or the afternoon performance. All right. So let's ignore this sentence for the moment. Let's just say construct the expression Janice would use to determine how much less she would spend if she chooses an afternoon show instead of an evening show. Okay. So how much would it cost if she wants to go in the evening? Like, how would you determine that? You don't have to actually get the amount. You just have to um, tell me how you're gonna.
24.50. And
Okay, is
wait,
that it?
that's the, wait, did you just ask what the evening price was?
No, I'm asking how you figure
Oh.
out how much it would cost total to go in the evening.
24.50 times 6.
Yes. And if you wanted to go in the afternoon,
Would be 19 times 6.
okay, and which is going to cost more?
The 24.50.
Okay. So how do you show the difference between them? What's that math operation for that?
Subtraction.
Yes. So you're going to take that 24.50 times 6 and subtract the 19 times 6 like that. Now let's talk about the answer, because I mean this is a little weird, but it's maybe you'll see something like this, so at least you'll have a fighting chance. You have to grab like they want you to grab the 24.50 and put it in the first box here. Like you would literally like drag it over, I guess. Maybe you've had some online classes where you've seen that before.
They could drag and drop into a box.
Yeah. And then so there's no multiplication, and that's bad. Okay. So we have to do this without, do you say there's no multiplication here?
Mm-hmm. It
That's
also
bad.
says use it on any term only once, so that means you can do the 6 twice. And there is no.
Okay. So do you see how there's a 6 in both of these?
Mm-hmm.
You can factor out a 6. Okay, so the 6 comes out, and then it's 24.50 minus 19. Now can we do the class? I'm sorry, now can we do now can we only use one of these each one time? Yeah. You can put the 6 in the first box, open parentheses, 24.50 minus 19, close parentheses. So it's kind of like a puzzle, I guess, where you kind of have to be able to do that.
Okay. I don't really understand the factoring part, but
Um, the I don't want to say this. We could. Do you want us to do a few more factoring problems, or do you want to just move on to another question?
I'm just not sure when it's applicable. Like this isn't something that I would have thought would include factoring. I just don't know when it like shows up
I
or
agree.
when I'm supposed to use it.
I agree. Like at first, I wasn't going to do any factoring, but then the answer wouldn't have fit, and you can only put it in one time. So if there's something that's common, you factor it out. So do you want us to do a few more factoring or move on to something else?
Let's move on, I guess.
Okay.
Because with factoring questions, I know specifically that's what I'm supposed to do, but it's when they pop up in random questions that I'm not sure when when I can use it.
So in a certain state, the legislature has 100 seats. All right. In 2010, Party X held 54 seats, which means we presume that the other party had 46 because it has to add up to 100. In the 2012 election, the party gained 2 seats. So that means X was at 54, but they went up. But in 2014, Party X loses 6 seats, but then they gain 2 seats in the 2016 election. What will be the absolute change in the number of seats held by Party X from 2010 to 2016? So what you really need to know here is, and you could make a little table. You could say, okay, year and seats. And I think this would be good exercise for you to do here is to give me, go ahead and read it, but give me the number of seats in each year here.
So 2010 had 54, 2012 had 56. And then 2014 they had 50, and then okay, and then gains 2 seats the next year. I thought it was loses and then gains in the same year. And then 2016 would be a 52.
Great. So the absolute change, I mean, we haven't talked about this, but the absolute change is just the difference. It's the new minus the old. Okay, and it's typically an
So
absolute value.
52 minus 54.
Yeah.
Would that be?
Well, it's the absolute value of negative 2.
Oh, okay, so you actually you do finish the whole thing.
Yes.
Like, okay, solve it. For a second, I wasn't sure if you just had to write the. All right, so it is -2, and then you put in absolute value.
So this is kind of an equation, kind of, maybe you already know it. I mean, I'm not sure. It's kind of a, yeah. So you could, I mean, you could like, there is another one for relative change, but absolute change is pretty good. Any questions, thoughts on that, follow up on that?
Mm-mm.
Okay, so we'll go to 22 next. All right, so what is the surface area of the cylinder below? So you have to know the formula for surface area. The surface area is 2 pi r squared plus 2 pi r 8, like that. All right, so can you tell me the value of r and h in this?
Oh, that's 2 HR squared plus pi. Is that an N or an H next to the first two? Or is that pi?
I'm sorry, this is pi, 2 pi r squared.
Oh, okay. So what do I find for R would be 2,
Okay, and
5 would be the height.
okay. So we talked about this. This is kind of a factoring thing. Do you see how both of these have a pi in it,
Mm-hmm.
and all the answers have a pi in it?
Mm-hmm.
So you wanna like ignore the pi. You wanna say, okay, it's 2r squared plus 2rh. See how that pi has been factored out?
Mm-hmm.
So I want you to do this part in here with the r and the h and see what you come up with.
Is it B?
Okay, so you go with b there. So it's 2 times 2 squared plus 2 times 2 times 5. So that's 8 plus 20. So it is 28 here. Very good. So there's a number of surface area formulas. I don't know what to suggest in terms of like, I mean, I don't think you want to gamble and not, I would just learn them all, but there's a lot there. It's not as easy as you think. Okay, 1P3, move on to 23 now.
Does this one have a canceling?
It does, like you're supposed to factor the numerator and the denominator, and something will jump out at you. There is kind of another way to do it, which is to put numbers in for x and then put numbers in for x. I don't recommend that, but that is a possibility here.
Because I noticed all the answers are just X. So, and it's 2X squared and 2X on the bottom. So it would just cancel out to be X, right?
No, you have to, they're in parentheses. So you have to factor the numerator, factor the denominator. If you're not sure what I mean by that, that's, we can go through that, but that is the idea here. You can't just cancel those. No.
Oh. Then what am I supposed to do with this one?
Well, again, we're going to factor the numerator. So let's just look at 2x squared minus 6x minus 36. Do you remember the very first type of factoring that we're supposed to always try?
Mm-mm.
Greatest common factor. So is there a number that goes into 2 and 6 and 36?
Two?
2. So what goes in parentheses here? What is each of these divided by 2?
One?
X squared, 1x squared, okay, or just x squared, okay.
1X squared.
Keep going.
3X.
Minus 3x.
18 or minus 18.
Yeah. Good. Okay, now the next type of factoring is if there's a 1 in front of the x squared, which this does have, is you have to factor this into 2 binomials. Okay, do you remember doing that at all?
Mm-mm.
So we did do a number of these. You're finding two numbers that multiply to minus 18, but add to minus 3. Multiplies to minus 18. But it adds to minus 3. So can you think of two numbers that multiply to minus 18? Or 18? I mean, 18 is fine as well.
-9.
And what else? Need two numbers that multiply. Two numbers that multiply to minus 18.
Oh,
So like you said, -9 is fine, but what does it go with?
2.
Okay. Does that add to minus 3? Does 2 plus minus
Probably
9 add to
not.
5? No. So like you got to try them, but there's so now is there something else that you can think of that multiplies to minus 18? Like 18 divided by 1 is 1 and minus 18.
6 and 3.
Okay, good.
Negative.
So is it 3 and -6 or -3 and 6? Which one adds to minus 3?
-6 and 3.
Okay, so that becomes x plus 3, x minus 6. Okay. That's the numerator. So now we're gonna do the same thing in the denominator. So now we're gonna look at 2x minus 12. What is the first type of factoring that we should always try?
GCF.
GCF. So is there a number that goes into both 2 and minus 12 or 2 and 12?
Mm. 2.
2. So now what goes in parentheses here?
1 x minus let me calculator 6 -6.
Okay, good. All right, so now we're going to take the top, so the 2x minus 3, or 2 times x plus 3, x minus 6, and then we're going to put this on the bottom. All right, so that's the that's the original here. Let me see if I can actually, I guess I've got it still in there. All right, let me just do a new snip here. Okay, so the numerator becomes this, the denominator becomes this. Do you follow? Like we did the top and then we did the bottom. Do you see that?
I kind of lost the plot. I forgot what we were even originally doing. Where did,
Okay.
how did we get? What was the point of the last thing that we did? I'm
That's
confused.
great. Well, we have to factor the top and we have to factor the bottom.
We
And they're
just did
two-
something. It had to do with adding things. Why did we do 2 types of factoring? I'm confused.
The problem required that. So we started out by factoring out a 2 from the top. Remember, we divided everything by 2. So that's x squared minus 3x minus 18. Then this part inside parentheses is another type of factoring. I call it A equals 1, but there's other kind of names for it. It's a but this part inside parentheses becomes a pair of binomials. That's where the whole multiplies to the last number, adds to the middle number.
But why does it do that?
That's, I mean, are you asking like why does it work, or like give
This
me-
like because you didn't really need to. Is it because there's 3 numbers?
yes, there's 3 terms. That's why you have to do this other type of factoring.
Okay.
And then so we did that other type of factoring, which we can do more of if you would like, but that's the top. So the top is done here in this line, but then we got to do the bottom. All right. So we got to do the bottom. So we did the bottom, the top, we did the bottom. Does anything cancel?
The x minus 6 and the 2's.
Okay, what is left over?
X plus 3.
Yep. Now, like I said, there is another way to do this problem. And I guess I think it's worth showing you that, but I don't think this factoring is something you're going to be able to, there's so much there. I just don't know that you're going to be able to do that on the exam. So you can always try numbers like let x equal 0. Okay. What is 0? If you imagine putting 0 in for x here, what happens when you square 0?
It's just 0.
And 2 times 0 is
0.
okay. Minus what is 6 times 0?
0.
Okay, so we got 0 minus 0 on the top, minus 36. Okay. All right. And this is kind of the way I would probably show you how to do a problem like this. 2 times 0 squared minus 6 times 0 minus 36 becomes minus 36. And then if we do the same thing on the bottom, what does that become? What is 2 times 0 minus 12?
Negative 12.
Okay, so what does negative 36 over negative 12? What does that reduce to?
3.
Reduces to 3. Good. Now, you still have to put 0 into each of these answers. When you put 0 into any of those answers, do you get 3? You already know the answer, but you know, is what is the first one? You know, what is 0 minus 6? Well, it's minus 6. What is 0 minus 3? It's minus 3. What is 0 plus 3? Oh, it's 3.
3.
So that's a strategy. Try some of the answers. Try a number. Let's see if it works. Do you want to do some more factoring? Do you want to do another problem like this?
We could do another problem like that, and I could try doing it the way of just plugging in numbers instead of doing it the first way. See if that works better.
Okay. Right. Yeah. Let me try that. Let me come up with one here then. Give me just a moment to make one up because these are harder to make up than you would think. So give me just a moment here. All right, so we got actually, sorry, we were doing y. Sorry, let me do y. Y equals
So would it work to just plug in 0?
0 is a good choice to try. You know, if you're gonna test something, test 0, maybe test 1, and then maybe -1, which I don't like, but that would be one to try there.
So 0 minus 0 minus 18. So negative, so the top would be negative 18. And then over 6. So negative 18 divided by 6 reduces to negative 3. So it would be x minus 3. Yeah, I think that works a little better than the factoring. The factoring takes longer.
Let's see, let's get a new problem up here. Customers of Paul's Beauty Supply can make purchases online from a catalog or in the store. Okay, so I guess that's like a takeoff on Sally's Beauty Supply, maybe. I don't know. So online sales, they're a little more than like 60, but see how it's in thousands. That's important. Catalog sales, I don't know, maybe 130,000. In-store sales are like 100,000. Okay. So it says about how much more, that's important, did the company make from catalog sales than from online sales?
So because the online sales, would that be like maybe 60 or no 65?
Sure.
Because it's like not quite in the middle. So I'd say that's like about 65, and then the catalog sales would be about 130.
Okay. So what is the answer?
So 130 minus 60. So about 65,000.
So again, not all questions are created equal. Like this one is just look at the graph, do some subtraction. So, you know, they call it like low hanging fruit, right? It's easier to pick things that are right there in front of you. Do problems like this, and don't get overwhelmed at first glance. You may find they're much easier than they appear. All right. Ready to move on to 25? Yes, no, maybe.
Yeah.
Okay. All right. So a little bit of, I should give you a little bit of information before we do 25. So this symbol and this symbol go with the open circle. This symbol and this symbol go with the filled in circle. Okay. Do you remember seeing that before?
Mm-mm.
Never seen this before. Okay. So maybe we did never cover it. All right.
I don't think I've ever. Yeah, I don't
Well,
think we
here's-
ever. Because I remember us covering just the regular inequality stuff, but the circles never came up.
Okay. So this is important though. It's like a little chart here, which says that if you have like this symbol or this symbol, it goes with the open circle. If you have this symbol with the line underneath and this symbol with the line underneath, it goes with the filled in one.
So lines are closed and no lines are open.
Right. So based on that, the first one is a filled in and the second one is an open. So which
So
of
it's either
these?
D or A.
Yes. Okay. Now, whenever you have X between the I call this between. You shade between or inside.
So it'd be D.
Yeah. But you need to know the inside, and then there's also this outside, which, I don't know how much to go into because it's one question, but maybe remember this is between, and then everything else is outside.
Okay. I don't know if I've ever seen a question where the outside one would be applicable. Because it's
It would
usually
be,
like between these two numbers.
yeah. So let me do this, because I think this would be good for you to have in your notes. Is let me just snip in the answers and give you the corresponding equations for these. Okay. So for letter A, maybe I should do these one at a time. Yeah, that will be better for your learning and understanding. Let me do a free form snip. All right. Yeah. I think this will be worth doing. So give me just, a little bit of flexibility here to do this. All right. So for A, this part over here on the left is X is less than or equal to -2. Okay. The less than or equal to the line underneath is the filled in circle. Because it's shaded left, that's why it's this less than. It's less than means to the left. Okay, over here on the right is X greater than 4. So it's open circle, that's why it's a greater than. The greater than means to the right. When it's the outside, you put the word or there.
Oh, okay.
Let's try another one here. Grab B. So here we go. We got X is less than -2 because it's open circle, or X is greater than or equal to 4 because it's a closed
Close
circle.
circle.
Yeah. And then I'll do C because we haven't done, we already have B from the answer. So this is the between. When it's between, you put X right in the middle. And because they're both filled in, it's the less than or equal to, less than or equal to.
Okay. That makes so it's the ones where it's like on the outside instead of the insides, it would be or.
Yep.
Okay.
Okay, so let's look at 26. We are running out of time, but we'll finish up the question for sure. So the way to do a lot of these is to try the answers. Okay, so it says here, at what point does the line with the equation y equals 2x plus 3 intersect with the line with the equation y equals -1/2 x minus 7? Okay, so what I would do if I were a student is I would try the answers. So I pick the one that I like the most. Which one do you like the most out of these?
C maybe.
Okay, doesn't matter to me. I'm just asking you. Let's try C first. So C means x is 0 and y is 3. So does it, like, it's got to work in both. So is 3 equal to 2 times 0 plus 3? So we're trying that one here first. Is this true? Is 2 times 0 plus 3 equal to 3?
I'm confused.
X is 0 and y is 3. Do you see I put 3 in for y and 0 in for x?
Yeah.
Right,
So yeah.
so does this work? Is 3 equal to 2 times 0 plus 3?
Yeah.
Okay, that's good. It's a good start. Now we do the same thing. We're at 3 equal -1/2 times 0 minus 7. Is this true?
I have no idea. No,
Well, why no? What about this isn't true?
because it doesn't add up.
You seem uncertain though. 0 times anything is 0. So is -7 the same as 3? No, That one's out.
So it's gotta be B?
No,
No,
we've eliminated
wait.
an answer. We've eliminated an answer. That's all we've done. So let's try B. Okay, so I'm gonna do the same thing here. Okay, so 0 is X, -7 is Y. Is -7 equal to 2 times 0 plus 3? Is this true?
So no, so it's not B either,
So it's not
but
B
I'm
either.
confused.
Okay,
What exactly are we doing?
we're putting the numbers in for X and Y. So which one do you want to try next? D or A?
D,
So D is the ordered pair 2, 7. So what's the X value in this ordered pair?
2?
2, and then Y is 7. So is 7 equal to 2 times 2 plus 3?
Yeah,
I agree. Now, is 7 equal to -1/2 times 2 minus 7?
no,
You seem uncertain about that. Like you gotta be fully committed to it. Like, is it? I'm not saying you're wrong. I just like don't like hearing the hesitation. You know,
no.
it is not.
I have no idea how to put in a calculator.
Well, half of 2 is 1, -1, -1 minus 7 is -8. Negative, not positive, so that's wrong. Which means that it must be A. I'm trying to show you that you can test the answers or try the answers as a strategy, and you could use it. Absolutely. All right, so we're gonna go ahead and stop here for today.